Hello everyone, I'm Dr. Ritu Arora from JDM College. Today I'm going to talk about cluster points. So let A be a subset of R. Now a point C belonging to R is said to be a cluster point of A if for every delta greater than 0, there exists at least one point X in A which is different from C such that distance between X and C is less than delta. In other words, a point C is a cluster point of the set A if every neighborhood of C contains at least one point of the set A which is distinct from C. That is, if I take intersection of the set A with the neighborhood of C, then that intersection must contain at least one point X such that X is not equal to C. Now we note here the point C, that is the cluster point, may or may not be in the set A. Now if we consider the example, let A be open interval 0, 1, then the set of cluster points of the set A is closed interval 0, 1. We observe here 0 and 1 are also its cluster points even if they are not in the set A. Because if I take intersection of any neighborhood of 0 with this set, it will contain elements which are different from 0. And same way, if I take intersection of any neighborhood of 1 with the set A, it will also contain elements different from 1. On the other hand, if I consider the set 0, 1, set of two elements 0 and 1, then 0 and 1 are not cluster points of this set. Because suppose I consider this neighborhood minus half to half of 0 and I take intersection with the set 0, 1, then that intersection is singleton 0. So in the intersection there is no element which is different from 0. Therefore, we can say that in this case 0 is not a cluster point of 0, 1, the set 0, 1. Similarly, 1 is also not cluster point of the set consisting of just two elements 0 and 1. In fact, this set has got no cluster point. Now, if I consider the set of natural numbers, integers, then even these sets have no cluster points. On the other hand, if I consider the set of rational numbers and real numbers, then every real number is a cluster point of these sets. Now, there is a very important result regarding cluster points. Now, if C is any cluster point, C is any cluster point of a set A in R, then there exists a sequence An in A such that limit of that sequence is the cluster point C, where each element of the sequence is different from C and vice versa. So the theorem goes like this: a number C belonging to R is a cluster point of a set A of R if and only if there exists a sequence An in A such that limit of An is C and An is different from C for all n belonging to set of natural numbers. Thank you.